wanted to briefly discuss naming alkyl halides and show you hopefully that it is very similar to the naming of alkanes that we learned about in Chapter 4. So the numbering scheme will remain the same, and in this case the bromine and the methyls get equivalent priority, which means that neither one of them deserves the lowest number. We're still going to number our chain so that we get whatever substituent is encountered first gets the lowest number. And in this case, we could number two different ways, 1, 2, 3, 4, 5, 6, of course, and that gives the bromine 2 and the two methyls 5. But we can do a little bit better by giving the two methyls 2 and the bromine 5. And this essentially keeps the same numbers, but we're going to get two 2's instead of two 5's. And so this works just a little better. So we're going to number this way. And so we have a 5-bromo, and of course we'll alphabetize that with the B, and then we have 2, 2 dimethyl, and then we have hexane across the bottom there. And there's one more feature that we want to look at, and we learned about that in Chapter 5. We want to make sure that we show our colleague, if we're talking about this molecule with somebody, tell them what the stereochemistry is at carbon number 5. And so we learned about that in Chapter 5. Highest priority is the bromine. Second highest priority is the right side of the molecule with all those carbons. Third highest priority is the methyl. And of course the hydrogen is in the back. And so I number 1, 2, 3. That's going to give me R. And so I have R, and that goes in the front of my molecule. So the name of this molecule is R in parentheses dash 5-bromo 2, 2 dash dimethyl hexane. You'll notice I don't have a number telling me where the R is, and that's because when I draw this molecule out, I will realize that there's only one spot that can be a stereocenter, and so we don't need a 5 right here for the R. If there were 2 or more stereocenters, we would need a number in front of each of those R and S and R to tell our colleague where those stereocenters are located. But if there's only one stereocenter, we don't need a number. And of course, just another aside about naming, some of the rules might seem a bit arbitrary, like alphabetizing or putting these numbers in certain positions. And they are arbitrary. They're just rules that are set up so that everybody comes up with the same name for the same exact molecule. Because we could write out this name, our 4-bromo 2 dimethyl hexane, and that of course would give us this molecule, which is different from the original green one that I had up on the screen to start this video. And so it's very important that we recognize that this little minor change tells us that we have a different molecule. And you can use this when evaluating pairs of molecules. If they have the exact same name following the exact same rules, they are the same. If their name differs in any way, again following the exact same rules, they are either constitutional isomers, as I've shown you here, simply by moving the bromine, or they could be completely different molecules, or they might just be stereoisomers if we change R to S, for example. So the naming is arbitrary. It's just a set of rules that had to be created so that it's easier for chemists to communicate the absolute same structure with other colleagues in the field. And certainly you could make up your own rules of naming, but that wouldn't be very useful if you wanted to talk about them with me, because I'm familiar with these rules. And so I hope you understand why we need to have these single set of rules here. Okay, second one. We have 2 chlorines here. We've got a stereocenter right there. Actually, this is a stereocenter too, so let's fix that. That's now a wedge. There we go. Alright, so first I think I want to do is assign the stereochemistry. So I have a 1 there, and then I have a carbon connected to a carbon and 2 H's. And right here I have a carbon connected to 2 carbons and an H. So that's higher priority, even though there's a chlorine further on down the chain. It doesn't matter right now. So there's my priorities here. So this is R. And then if I look at this stereocenter, I've got a carbon connected to a chlorine, so that's going to be highest priority. Let's use a different color there. So highest priority is the carbon connected to the chlorine, then the branch chain, and then the ethyl, and that is S. So I have R and S in this case, and so the first part of my name should be, well, first I need to figure out what my numbering will be, and I'm going to have to erase all of these extra numbers around here so we don't get confused. So sometimes it helps to be able to maybe make a second drawing or erase them as I'm doing right now. Okay, I'm going to put this S back here. I want to make sure I don't forget about that. And then I want to number the chain, and I think I want to use this as my main chain because it has the longest continuous chain of carbons and the most branches. I could have gone straight across, but I would have lost a branch. And then I want to start right here because that gives me a 1 chlorine. So that's going to be the lowest number for a substituent. So that's how I'm going to number that. Again, I have hexane. And now I have numbers for my stereocenters. So you can see I can start with 3R, comma, 4S. And that's how I'd put multiple stereocenters in the front. And then I'm going to have a dichloro, 1, 3 dichloro. And then I have a 4-ethyl, it looks like. I'm just going to write that right here so I don't forget about it. And I have a 5-methyl. And then the last one, of course, is again hexane. So I alphabetize these again: 4-ethyl, 5-methyl, hexane. So you'll notice that I have my stereocenters are indicated with their location and their configuration, and then I have alphabetized by C, E, and M. And of course, if any of these numbers changed, if I had 1,4-dichloro instead of 1,3-dichloro, I know that that's a different molecule. It would have a certain relationship to my first one, but it's not the same one because its name is different. And again, that's why we need to follow these seemingly arbitrary rules and learn how to use them and follow the rules so that we can all come up with the same name for this compound.